Hello everyone, I'm Professor Ken Vakthure. Today we are going to study the cycloidal motion, which is used as a follower motion in case of cam and follower while designing the cam. In this today's session, we are going to study its graphical method as well as its mathematical modeling. There are total four types of follower motions we normally use. One is the uniform velocity, uniform acceleration retardation, simple harmonic motion, and the cycloidal motion, out of which today we are going to study the cycloidal motion. The objective of this session, to aware you about the how to draw this displacement diagram using the cycloidal motion, and the after completion of this session, student will able to use this concept or to this displacement diagram to design the cam for a particular application according to the different that uh, uh, cam angle rotation, that means theta outstroke angle or the particular return stroke angle. These are the some notations that we are going to study. That means that we are going to consider while drawing the displacement diagram and the that mathematical modeling. S is the stroke length, omega is the angular velocity, theta will be the cam angle, theta O is the outstroke angle, theta DO is the dwell after outstroke, theta R is the return stroke, and theta D are the dwell after the return stroke. Outstroke means angle through which that follower moves in the upward direction, and the return stroke means that follower moves to its original position, which is the return stroke. Now this is the cycloidal motion. This is the displacement diagram. I'll just mark that. This is the displacement diagram. This is the velocity diagram, and this is the acceleration diagram. This profile that we have to draw, and that we have to learn how to draw this displacement diagram for by using the cycloidal motion. Now we will consider its mathematical modeling. This is the equation for the cycloidal motion that we know. Yes, where theta is the for particular cam. Suppose I want to find out the displacement at this location. This is the x. That vertical distance is the x, and that horizontal distance is the cam angle. For particular angle, suppose we want to find out the x. This is the equation we need to follow. S is equal to, using the cycloidal motion, S is that x is equal to S into bracket theta upon theta O minus 1 upon 2 pi sin of 2 pi theta upon theta O. If we differentiate this equation, we will find the equation of the velocity. We differentiate this equation again. If we okay, now we are going to find out the maximum value of this maximum velocity. Now we know that by using this equation I want to find out the maximum velocity. To have that maximum velocity, this term must be maximum, and to have this maximum velocity, this term, this cos 2 pi theta upon theta, which should be minimum. We know the minimum value of that cosine, which is of -1. When we get that value, when that theta, this total angle is equal to pi. Now if we modify this or simplify this, we will find theta is equal to theta O by 2. Again, when we put this theta is equal to theta O by 2 in this equation, it becomes 2 into s into omega, because this is of -1 minus which becomes the plus, which 1 plus 2, 1 is the 2, means 2s omega upon theta O. That maximum velocity for the cycloidal motion, which is of 2s omega upon theta O. Next one is the, if we differentiate this velocity equation, we will find this equation, that minus cosine, which is the sine. We will find this equation. Now again, in this case also we have to find out the maximum velocity. To have this maximum velocity, this value should be maximum, and when we get that maximum, when either theta is equal to pi by 2 or the theta, that means this total angle is of pi by 2 or the 3 pi by 2. Okay, when we put this theta is equal to, this total angle is of pi by 2, that means theta is equal to theta O by 4. That means this is of theta O, this total angle is of theta O, this total angle is of theta O, this is of theta O by 2, and this is of theta O by 4, at which we will find out the maximum acceleration, and that maximum acceleration is of this. The beauty of this cycloidal motion is that that displacement, velocity, and acceleration, which are started with the displacement, zero velocity and the zero acceleration. And because of this, for the high speed application, we'll find the gradual increment of this that follower, and there is no any sudden jerk takes place that we have observed in the uniform velocity, uniform acceleration retardation, and the in the simple harmonic motion. But in this uniform acceleration, in this cyclical motion, there is no any such a chance to have that sudden rise. And because of this cyclical motion which is implemented for the high speed application, this is the very important point of this cyclical motion. Now we'll study how to draw the cyclical motion using the graphical method. First of all, you have to draw one horizontal line, its length is equal to 180 mm. Next, you have to draw one vertical line through this initial point, its length is equal to stroke length. Okay, now this horizontal part is the cam angle, vertical is the denotes the displacement of the follower. Now this we have to divide into the four parts. Theta O is equal to 60 mm. We have to take that theta O is equal to 60 mm, theta DO is equal to 20 mm, theta R is equal to 60 mm, and theta DR is equal to 40 mm. Irrespective of any angle of this, you have to take this distances remains same. This distance should be same. Okay. Now suppose this may be the any angle, theta is equal to 120 degrees, it may be of 100 degrees, still you have to take this distance is equal to 60 mm. For any angle you have to take this distance is equal to 60 mm. Okay, next we have to draw the vertical lines. The total height is equal to stroke length which is given to you. Next we have to divide this theta O and theta R into the 6 equal parts that we have divided into the 6 equal parts. You have to give the numbering 1 2 3 4 up to the 14. Next again through these points we have to draw the vertical lines. Now here in this case you have to draw one diagonal line, this diagonal line like this through this theta O. This is the start point and this is one rectangle that you will find, and through this point this diagonal you have to draw. On that diagonal we have to consider any one point. On that you have to draw one circle, and the radius of that circle is equal to R is equal to S upon 2 pi. That stroke length will be given to you, and we will find out this total radius. The cycloidal curve, that means what is the significance of this? If you allow to rotate this radius circle over this, and when we trace the center point or the point of contact, or suppose that circle is at this location, and we allow to roll, and when we allow to roll over this vertical surface, this profile traces one curve which is called as the cycloidal profile. We have to just take the horizontal distance, vertical distances. Okay, now this you have to draw one horizontal line through this point. Just concentrate over here. Next, from this point you have to divide this circle into the 6 equal parts. From this reference you have to take the 6 equal parts, that means 60 degrees 60 degrees 60 degrees. Through this point you have to draw one vertical line. Again you have to mark the intercept through this point, that means this intercept are the coincidence. Okay, next you have to give the numbering. That numbering should be starts from this position: 1a, 2b, 3c, 4d, 5e, and the 6f. Next you have to mark their center points, and through this point you have to draw one line. This must be parallel to this must be parallel to this dotted line, okay, and this line intersects that vertical line at point A and vertical line 2 at point B. Okay, that means we have marked this A and B. Next, consider this line, the second line, which intersect 3 at C and 6 at F, 3 at C and 6 at F, and this line which passing through this, which intersects that 4 at D. You have to mark this line which should be start from this position. By mistake I have just drawn this 4 from D, that means which intersect 4 at D and 5 at E. Okay, now and you have to draw this curve through this point A, B, C, D, E, F, and you will find this profile for the displacement diagram. Now next portion is the, now you have to draw, I'll draw this is the dwell. Again You have to again draw one circle during return stroke. Again it's you have to follow the same procedure. Again you have to draw the that parallel lines which are parallel to the diagonal lines. You have to mark that intercepts, and these intercepts intersect again. While marking this, here ends with the 7G. Next one is the 8H, 9I, 10J. You have to mark that from this position in a anti-clockwise direction. 11K and the 12L. And you have to mark their intercepts. You will find this cam profile like this. Through this point G, H, I, J, K, L, M, and next part is the you have to draw this horizontal line which is the dwell during the after the return stroke. In this way we have to draw this total cycloidal motion, and this, and by taking this distances 1A, 2B, 3C, 4D like this, you have to take these distances while drawing the cam profile. With this we are going to finish over here. We have started with the mathematical modeling, ends with the graphical method. Again, because of its smooth nature, there is no any jerk at the start and the end of this operation. That's why this profile which is highly recommended for the high speed application. With this I will finish my task over here, session over here. Thank you for your patient listening. Thank you very much.